Alright, we're going to do a fairly challenging one this time. So again, if you want to review the other two first, you might want to go back and watch those videos again. This time we're going to do, notice we have another complex root, but it's a binomial. Last time I just gave you 3i, which is a monomial. This time it's a little bit more challenging because of the binomial aspect here. Alright, conjugates come in pairs. I'm sorry, I said that wrong. Complex numbers, complex roots come in pairs. So if 1 plus I is a root, then 1 minus I is also a root. So we found 2 of the 3 already. There's a total of 3 roots. We're going to do the same process we did on example 2. We're going to multiply these together, come up with our quadratic, divide the cubic by the quadratic, and then we'll end up with something that, a linear, hopefully, that we can solve and find the third root. Okay. Rather than foiling these together, okay, because first we'd have to make them, let me show you. These are roots, so this is what x equals. Okay. When I make those into factors, I have to subtract the entire binomial. These are not, they are binomials, but they are not factors because they don't have an x in them. I have to turn them into factors by setting them equal to 0 and subtracting. So if I were going to use the multiplication process, then this is what I would be multiplying together. Okay? So it's not a FOIL problem because these are trinomials. You can certainly do that, and there is a trick for doing it a little bit faster, but the way I want to multiply them together is to go back to last semester and review our product and sum rules, where we talked about the sum of 2 roots of a quadratic equaling negative b over a, and the product of 2 roots equaling c over a. Okay? I have my 2 roots, 1 plus I and 1 minus I. If I add those together, the first root and the second root together, I will get the ratio negative b over a. And remember, a quadratic is of this form. So if I can find a, b, and c, then I've got this nice quadratic rather than multiplying these out. Okay, so let's add these together. 1 plus 1 is 2. I plus negative I is 0. Alright, so that doesn't factor into our problem. So 2 over 1 is the same as negative b over a. The sum of the 2 roots is negative b over a. So I added the 2 roots together, I get negative b over a. So right now I can see that a is 1 and positive b is negative 2. Now the product rule says if we multiply these together, we will get the ratio c over a. So let's FOIL these. It's conjugate, so I can kind of cheat the FOIL process. I know the outside and inside terms are going to cancel out, so I really don't even need to multiply them together. So I can just do the first 2 terms and my last 2 terms. Remember that I squared is really negative 1, so we are actually getting, again, for C, 2. That usually doesn't happen where you get the same number for both the product and the sum, but we got lucky this time. So this is c over a. I'm confirming a is in fact 1, which I already predicted. And now I see that c is 2. Alright, so when I go and plug those back into my generic quadratic, the standard form, I see that multiplying these 2 factors together is going to result in the quadratic 2x squared. Oops, that should be a 1, huh? 1x squared minus 2x plus 2. That is my quadratic. Alright, I took my a, b, and c and plugged them in here, here, and here. Now I have the 2 factors multiplied together. A little bit simpler than had you done it straightforward. Okay, so we're back to long division. Just like in the last example, I can't use synthetic here because, again, I have a quadratic, and synthetic is reserved for linear binomials. X cubed minus 5x squared plus 8x minus 6. What do I have to multiply x squared by to get x cubed? Well, that's just an x. Multiply back through. subtract everything in here. So this is going to cancel to 0. We have negative 5 minus a negative 2. It's going to make that a plus 2. 8x minus 2x. Bring down my negative 6. Okay, what do I have to multiply x squared by to get negative 3x squared? Negative 3. Multiply back through, and we have negative 3x squared plus 6x minus 6. Notice on this example and the last one I'm getting zeros, and that's because I'm working with factors. Okay, I'm working with zeros, and that means that by the remainder theorem I will always be getting a 0. So if you're not getting zeros here, then that means you've either come up with the wrong quadratic or you've done something wrong in your multiplication. Okay, you should always be getting zeros when working with factors. Okay, this is our third factor, x minus 3. I want to change that into a root. Alright, factor has the x in it. A root is when you set it equal to 0 and you solve. So my root is 3. I was given one root. I knew that its conjugate pair was another root, and I solved for the third root. Those are the solutions to this problem.